Part 2. Using colour spaces to order colour. Imagine yourself stranded on a desert island. Help is on its way, but you are utterly bored. One of the beaches is covered with pebbles of all kinds of colours. Just to pass the time and keep your mind at work, you grab a handful and start sorting the pebbles. Maybe you already have some ideas on how to achieve a nice sequence. First, you try and sort them by the colours of the rainbow, but quickly you find that this doesn't really work. Several pebbles have a colour that's not found in the rainbow. So where do you place these white, black, brown and pink pebbles? Let's start over. This time you sort the pebbles from dark to light. At least that works for all pebbles, but there are still some problems. The resulting line of pebbles still doesn't look like a smooth gradient. Red pebbles are next to green pebbles, just because they have the same lightness. It's clear that defining any kind of order in colour is a real challenge, and in fact it's impossible to describe colour uniquely just by one single scale. You will need at least 3 different values. This is where colour spaces are used. A colour space defines a set of scales or axes along which colours can be arranged in a smooth gradient. One of the most commonly used colour spaces in quality control is that of L star, A star, B star, or CIELAB. Any visible colour can be described by these 3 parameters. Within L star, A star, B star, the L star represents lightness. It scales colour from black to white. Besides lightness, there's also a green to red axis, represented by A star. The greener a colour, the more negative the A star value becomes. A large positive value of A star represents a strong red colour. Likewise, there's also a blue to yellow axis, which is represented by B star. When A star and B star are both 0 or close to, it means that the colour is neutral or achromatic. This is the case for colours like white, black and grey. The nice property of the L star, A star, B star colour space is that it is perceptually uniform. This means that the difference of 5 L star between 2 samples is just as noticeable as a difference of 5 B star. Depending on the industry that you work in, you may be using other colour spaces such as XYZ, LCH, or little x, little y, big Y. Although these colour spaces each have different scales, their purpose is the same. They're all there to help you make sense of your pile of pebbles. Looking at the 2D representation of the L star, A star, B star space, or the AB axis, you can perhaps understand that it is possible to standardise the way we discuss colour. If it was necessary to describe colour over the phone, terms like redder, bluer, greener, yellower, and terms like brighter as the colour moves out from the centre. The benefit for producers and brands of attributing numbers to colour in this manner is that it allows us to quantify colour, colour tolerances and colour difference. It allows us to send colour over an email or discuss colour on a phone call, instead of, or at least in partnership with, physical samples in person. Digital colour data has several advantages over the sending of physical standards. Physical standards are often costly to produce and send. They require careful storage and handling, require skilled and controlled visual assessments by trained and experienced observers, and they can still leave producers open to subjective colour complaints. Using digital colour data, collaboration and communication with supply partners, organisations can set traceable and quantifiable agreements over product colour, often saving time, cost and reducing waste.